So, in the third lecture of current electricity, today I am going to derive these two expressions. One first is the expression of drift velocity Vd equals to A into tau. What is A? A is acceleration of the electrons. Electrons means here free electrons. And tau is average relaxation time. And second is the expression of electric current in terms of the drift velocity. So, these two derivations today I will explain. Now, see here, in the previous lecture I have explained that within a metallic conductor, free electrons are moving through the vacant spaces between the positive ions. Here in this diagram I have not shown positive ions. So, these free electrons are moving randomly here and there inside the conductor. Means they are not moving in a fixed direction, and because of this there will be no net current due to this motion of the free electrons. This motion of free electrons will not constitute any current in the conductor. This motion we call it the thermal motion. And why thermal motion? Because the motion is due to the thermal energy of the conductor. So, thermal motion of the electrons will not constitute any electric current. And why? Because electrons are moving randomly. Current produced by one electron will be neutralized by the other electrons. In other words, we can say that equal number of electrons are crossing to any cross section from either side. मतलब क्या है? अगर 1 मिनट में 100 इलेक्ट्रॉन्स इधर से इधर जा रहे हैं, देन इन द सेम 1 मिनट 100 इलेक्ट्रॉन्स विल मूव इन द अपोजिट डायरेक्शन. देयरफॉर द नेट फ्लो ऑफ चार्ज थ्रू दिस क्रॉस सेक्शन विल बी 0, एंड व्हेन नेट फ्लो ऑफ चार्ज विल बी 0, करंट विल बिकम 0. 0 upon t, that is equal to, it will become 0. It is clear? Means thermal motion is not constituting any electric current. We can also say that the average thermal velocity of the free electrons, as you know that thermal velocity of the free electrons, it is of the order of 10 to the power 5 meter per second. But the average thermal velocity, it will be 0. If we assume that there are capital N free electrons in this conductor, and पहले की थर्मल वेलोसिटी u1, दूसरे की u2 एंड nth की un, अगर इनका हम एवरेज निकालें, सो वी विल डू द वेक्टर सम ऑफ ऑल दीज डिवाइडेड बाई n. इट विल बी 0. एंड वाई इट विल बी 0? बिकॉज देयर इज नो करंट ड्यू टू द थर्मल मोशन ऑफ द फ्री इलेक्ट्रॉन्स. फ्री इलेक्ट्रॉन्स का जो थर्मल मोशन है ये कोई भी करंट प्रोड्यूस नहीं करता है. एवरेज थर्मल वेलोसिटी फ्री इलेक्ट्रॉन्स की क्या है? 0 है. व्हाट इज वेक्टर u1, वेक्टर u2 एंड सो ऑन वेक्टर un? दीज आर द थर्मल वेलोसिटीज ऑफ द फ्री इलेक्ट्रॉन्स. इट्स क्लियर? नाउ सी हियर व्हाट विल हैपन व्हेन यू विल अप्लाई ए पोटेंशियल डिफरेंस. व्हेन यू विल अप्लाई ए पोटेंशियल डिफरेंस, देन व्हाट विल हैपन? सो यू सी इन द डायग्राम, व्हेन ए पोटेंशियल डिफरेंस इज अप्लाइड, लेट मी मेक द डायग्राम. This is connected to the battery. This is the positive terminal of battery. This will be negative. Means this end will be at higher potential. This end will be at lower potential. If we take potential difference V, then what will happen? An electric field will be developed all across the length of conductor. And what will be the direction of that electric field? Direction of electric field E equals to, if we assume that the length of the conductor is L, तो हमको तो मालूम ही है कि इलेक्ट्रिक फील्ड क्या होती? पोटेंशियल ग्रेडियंट के बराबर, पोटेंशियल ड्रॉप पर यूनिट लेंथ. देयरफॉर इट विल बी इक्वल टू V upon L. दिस विल बी द इलेक्ट्रिक फील्ड. बिकॉज ऑफ दिस इलेक्ट्रिक फील्ड, every free electron will experience a force in what direction? Opposite to electric field. क्यों? क्योंकि फ्री इलेक्ट्रॉन क्या है? इलेक्ट्रॉन क्या है? एक निगेटिवली चार्ज पार्टिकल है. एंड ऑन ए निगेटिवली चार्ज पार्टिकल, व्हाट इज द डायरेक्शन ऑफ फोर्स? It is opposite to the direction of electric field. So what will be the magnitude of this force, electric force? it is Q into capital E. What is Q on the free electron, जिसको स्मॉल e से डिनोट करते हैं, जिसकी वैल्यू होती 1.6 इंटू 10⁻⁻19 कूलम इंटू E. So on every free electron this much electric force will act directed towards the higher potential end. It's clear? So what will happen? Every free electron will get accelerated towards the higher potential end. What will be the acceleration? It will be force upon mass of the electron. M is what? Mass of the electron. Means this much acceleration will produce due to the potential difference. पोटेंशियल डिफरेंस के कारण फ्री इलेक्ट्रॉन्स पर इतना एक्सीलरेशन प्रोड्यूस हो जाएगा. बट बिकॉज ऑफ दिस इलेक्ट्रिक फोर्स, बिकॉज ऑफ दिस एक्सीलरेशन, free electrons will not accelerate continuously. They will not accelerate continuously. Why? Because they have to pass through vacant spaces between the positive ions. When they pass through the vacant spaces between the positive ions, what will happen? They suffer collision with the positive ions. During the collision, they lose whole of their energy and come momentarily at rest. Momentarily at rest मतलब एक क्षण के लिए वो रेस्ट पर आ जाएंगे. But because of this existing electric force, जो फोर्स अभी भी लग रहा है, because of this existing acceleration, once again they will accelerate towards the higher potential end. Therefore, this electric force, this acceleration will not provide them a continuously increasing velocity. उनको एक continuously increasing velocity नहीं provide करेगा. It merely provides just a drift to the free electron in between two collisions. It merely provides a drift to the free electron in between two collisions. So see here, in place of acquiring a continuously increasing velocity, they will acquire a constant average velocity, which is called the drift velocity. Which is called the drift velocity. Means what is the drift velocity? It is the constant word is very important. It is the constant average velocity acquired by the free electrons under the influence of potential difference. It's called the drift velocity. It is called the drift velocity. Now see here. Here we will derive the expression of the drift velocity. Suppose there are n electrons in this conductor. There are how many free electrons? Capital N free electrons. 1, 2, 3 and so on n. Let the first electron is having velocity u1 just after a collision. Just after a collision, suppose this electron is this, it suffers collision with this positive ion. Just after the collision, its velocity of this electron is u1. It's clear? At that moment, it will have the thermal velocity component. At that moment, just after the collision, the velocity which is produced due to the potential difference will become 0. It will only have the thermal velocity component. So see here, let just after collision, it has velocity u1. And let its next collision with the other positive ion takes place in time t1. मतलब क्या है, ये इलेक्ट्रॉन इस पॉजिटिव आयन से कोलाइड करने के बाद दूसरे पॉजिटिव आयन से कोलाइड करता है इन व्हाट टाइम? इन टाइम t1. सो सी हियर, जस्ट आफ्टर कोलिजन इट्स वेलोसिटी इज u1. फ्री इलेक्ट्रॉन की जस्ट आफ्टर कोलिजन वेलोसिटी क्या है? u1 है. Now in between these two collisions it accelerates with what acceleration? Which already I have told, A equals to E into E upon m. It is clear? This acceleration is also directed towards the higher potential end. So what will be its velocity after time t1? What will be its velocity after time t1? So its velocity after time t1 will be vector v1 equals to vector u1 plus vector a t1. It's clear? This will be the velocity of the first electron after the before colliding to any electron. Now see here, what will be for the second electron? It will be vector v2 equals to vector u2 vector a tau t2. There will be similar expression for all the n electrons. This is the velocity of free electrons under the influence of potential difference. Velocity of free electrons under the influence of potential difference. This. So if you find out the average velocity of free electrons under the influence of potential difference, and as already we know that average velocity of free electron under the influence of potential difference is called drift velocity. So how will you find average? So average can be found by adding all of them divided by कैपिटल N. इनको ऐड कर लें और कैपिटल N से डिवाइड कर दें, तो लेफ्ट हैंड साइड में वेक्टर v1. दिस इज व्हाट? दिस इज द एवरेज वेलोसिटी ऑफ, you can write average velocity of free electrons under the influence of potential difference. Average velocity of free electrons under the influence of potential difference. It is equal to vector u1 plus vector u2 plus vector un divided by n. Now here a you can take out common, so vector a, it is t1, this is tn, t1 plus t2 plus and so on plus tn divided by n. This is the average velocity of free electrons under the influence of potential difference. Now as already you know that this is the average thermal velocity which is 0, which is 0. This is what? This is the time spent by the first electron in between two successive collisions, time spent by the second electron in between two successive collisions, and this time we call it the relaxation time. So what will be this? This will become average relaxation time. It is the average time spent by free electrons in between two successive collisions, and this time it is of the order of 10 to the power minus 5 second. 10 to the power minus 5 second. So see here, and this average relaxation time will represent by symbol tau. It is a Greek letter tau, T-A-U. This is already I have told that it is the drift velocity. It is the average velocity acquired by the free electrons under the influence of potential difference. So you can see here, if you write it here, so it will become vector Vd equals to 0 plus vector A into tau, means vector Vd equals to vector A into tau. This is one expression. Here you can see that vector A and vector Vd both will be directed in the same direction. Why they are directed in the same direction? You can see here, एक्सीलरेशन की डायरेक्शन वही होगी जो फोर्स की डायरेक्शन है. फोर्स की डायरेक्शन क्या है? ये है. देयरफॉर दिस इज द डायरेक्शन ऑफ एक्सीलरेशन. दिस इज आल्सो द डायरेक्शन ऑफ ड्रिफ्ट वेलोसिटी. Drift velocity directed towards the higher potential end. It is clear. Now as you know that vector A you can write. So in scalar form, how will you write? If you write vector A, this vector A, it will be equal to minus E into vector E upon m. क्यों माइनस लगा है वेक्टर फॉर्म में? स्केलर फॉर्म में तो लगाया नहीं जाएगा. यहाँ माइनस क्यों लगा है? वेक्टर ए इज टूवर्ड्स हाइयर पोटेंशियल एंड वाइल द वेक्टर ई it is electric field vector, it is towards the lower potential end. Both are oppositely directed. So you can write vector Vd equals to minus E vector E tau upon m, or in scalar form if you write it, means deleting the vector sign. So it will be E tau upon m. It's clear? This will be the drift velocity. Now as you know that E can be written as V upon L. When you will write this, so Vd equals to E, in place of capital E you can write V upon L. So it will become V upon m into L. V tau upon m into L. So these are the expressions for the drift velocity. It's clear? In scalar form also here you can remove this. In scalar form it will become this. Now after this we will deduce the expression for electric current I. I equals to NEA Vd. We will deduce this expression. You can see here. Suppose this is a conductor of uniform cross section. Though whether it is deduced for uniform cross section or non-uniform cross section, in every case it will be true. One more thing which I want to tell you, that what is the order of drift velocity? 10 to the power minus 4 meter per second to 10 to the power minus 5 meter per second. 10 की पावर माइनस 4 से 10 की पावर माइनस 5 मीटर पर सेकेंड. So suppose this is a conductor of length L, let its area of cross section is A. Let on applying a potential difference capital V, free electrons acquire a drift velocity Vd. They will acquire a drift velocity Vd in what direction? In the towards the higher potential end. This is the higher potential end, this is the lower potential end. Now what is the meaning of this? Suppose Vd is equal to 1 millimeter per second. Vd is equal to 1 millimeter per second. Electrons are moving in what direction here? They are moving in this direction. You take this cross section. So इस क्रॉस सेक्शन से 1 मिलीमीटर पीछे जो इलेक्ट्रॉन्स होंगे, सपोज अनदर क्रॉस सेक्शन इज दिस, अनदर क्रॉस सेक्शन इज दिस, एंड इनके बीच की डिस्टेंस क्या है? 1 mm, मतलब Vd के इक्वल है. कितने के इक्वल है? Vd के इक्वल है. सो द इलेक्ट्रॉन्स विच आर हियर, दे विल क्रॉस टू दिस क्रॉस सेक्शन आफ्टर 1 second. It's clear? Electrons which are present here, they will reach here after 1 second. Means electrons present in this region will cross to this cross section in 1 second. It's clear? In other words, here we can say in terms of Vd, electrons which are present in the Vd length of the conductor, electrons which are present in the Vd length of the conductor will cross to any cross section in 1 second. Now how many electrons are present in the Vd length? So first you find out this volume. This is in cylindrical shape, so volume will be equal to what? Volume of Vd length of conductor will be equal to length multiplied by area of cross section. Now in this volume there will be how many free electrons? So see here, if we assume that free electron density is small n, free electron density means number of free electrons per unit volume. One volume में, unit volume में this much number of free electrons. So there will be how many free electrons in this volume? So it will be Vd into A into n. It's clear? Number of free electrons present in this volume. It's clear? Means this much number of electrons will cross to any cross section in 1 second. इतने इलेक्ट्रॉन्स किसी क्रॉस सेक्शन को 1 सेकंड में क्रॉस कर जाएंगे. So how much amount of charge will flow in 1 second? It will be equal to number of electrons multiplied by charge on 1 electron. Charge on 1 electron means this much charge will flow in 1 second. So what is current? Current equals to Q upon T. It is equal to Vd into A into N into E. E is what? Charge on 1 electron divided by 1 second. Means current will be given by NEAVD. This will be the expression of the current. This will be the expression of the current. You can see once again. If the drift velocity is Vd, then the electrons which are present in the Vd length will cross to any cross section in 1 second. Now, how many electrons are present in this length? Electrons means free electrons. So, we will find out the volume of this length of conductor. Volume of this length of conductor. Volume equals to length into area of cross section. So, Vd into A. It is clear? So, in unit volume, how many free electrons are present? This. So, in this much volume, how many electrons are present? Volume into N. इतने इलेक्ट्रॉन्स पर चार्ज कितना होगा? इतना होगा. एक इलेक्ट्रॉन के चार्ज से मल्टीप्लाई करने. मीन्स this much charge will flow through the conductor in 1 second. So, current will be this. Now, what will be the current density here? Current density J equals to I upon A. As you know that current density is defined as current flowing per unit area of cross section. It is a vector quantity, and what will be the direction of J? It is in the direction of current. Direction of current मतलब इलेक्ट्रॉन के डायरेक्शन के अपोजिट. इलेक्ट्रॉन की डायरेक्शन के अपोजिट. इलेक्ट्रॉन जिधर जा रहे हैं उसके अपोजिट. So what will be I upon A from here? If you see, so it will be I upon A will be N into E into Vd. This will be clear to you. Current density J equals to I N into E into Vd. N is free electron density, E charge on 1 electron, Vd drift velocity. If you write this expression in vector form, so you can see here J is in this direction while Vd is what? In opposite direction. Vd is the drift velocity of free electron which is directed towards the higher potential end. Both are in opposite direction. So in vector form we will write minus N into E into Vd. This will be the vector expression. So this is all about in this lecture. In next lecture we will explain, I will explain you mobility of electrons and perhaps Ohm's law also.